So we've got some a tile pattern shape here created with algebra tiles, and we're asked to identify both. To find the perimeter of the shape that was created with algebra tiles. And I didn't notice it, but it does say down below that, hey, I'd like the perimeter and the area. Most of you, almost all of you, got the area correct, right? So if I'm looking at this, the area of this is I have a, whoops, let me get back out here. I have a single x squared tile, and then I have 1, 2, 3 x's, and I have 1, 2, 3 unit tiles. So the area of this was really straightforward. It is x squared plus 3x plus 3. That's the area. The perimeter is varying degrees of difficulty for some of us. So I'm going to color code this. If I look at this length from here to here is x units long. And if I go from here to here, this is also x units long. And the area of a square, if I multiply this x times this x, that's where the x squared comes from, right? X times x is x squared. So I've got two of these dimensions, two pieces already, right? There's an x and an x. The other thing I've got here is I've got units. So this, we've already decided that this was x units long. I'm using red for that. So this is x units long, right? Because it's a square, it was x units long over here. This piece right here is 1 unit long. This is the unit dimension. So 1 times x gives me x, right? So if you look at it, I've got a 1, another 1, and I've got a 1, 1, 1 as I wrap around. I'm going to skip this piece for a little bit. I'll highlight it in green because it's special. We'll come back to that green one in a minute. But let's continue with our units. I've got a 1, a 1, a 1. This piece right here is also special. It's not the same as the other one, but we're going to have to think about this piece a little bit. But I continue on with my ones. I've got a 1, a 1, a 1, a 1, and a 1. So far, without considering the two special green pieces, what do we have? Well, you can see I've got two x's so far, right? I've got two x's. There's 1, 2 x's, and then how many units do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 13 of them. So I've got 2x plus the number 13. Okay, so now let's think about the two pieces that are shown in green. So let's think about this one first. If I look at this piece right here, well, it's comprised of an X tile, right? A tile that goes from here to here, but part of that X tile is taken away. In fact, the part that's taken away was 1 unit long. So that means what remains had to be the X tile minus 1. Right? So this part is an X minus 1. And similarly, this part over here, again, this was composed of an X tile, this X tile rather, but we took away 1, 2 from it, so that left us this little piece here. So this is an X minus 2. So if I add these to the perimeter that I've got so far, I can add plus an X minus 1, and then I can say plus an X minus 2. Well, when I look at this expression, I now have 4 x's, right? There's 1, 2, 3, 4 x's. So in total, there's 4 x's that are being added together. And then I've got 13 minus 1, 2, 3. 13 minus 3 is 10. So the perimeter of this is 4 x lengths plus 10 unit lengths. And again, the area of that was x squared, x squared, it's just jumping all over the place, x squared plus 3x, and then plus 3.